In today's video, we're going to take a look at the equations of hyperbolas and their graphs. If you're in good shape with the circles and the ellipses so far, this won't be much more difficult. There's just a few added steps and a few other things we have to think about with hyperbolas. So the first thing I want you to do is you have a sheet already with this equation on it. I want you to take this equation right now and put it into HK form. You should pause the video right now, take a few minutes and do that. I'll warn you to be careful with your signs, but go ahead and turn it into HK form and then we can continue. Okay, so hopefully you've turned the equation to HK form, and we are going to look at hyperbolas. Now what's interesting about hyperbolas is that there's actually two different cases that we need to consider. And the first one we're going to look at is this one, and there are two Desmos files I'm going to reference here, and they're both available to you on Edmodo, so I hope you make use of them. The first one is this one, and when you turned your equation to HK form, you should have gotten this equation here, and hopefully you did. You can verify whether or not that's correct. But also there's a second one that we looked at in class that's like this. And you take a look between the two and they may not look all that different, but what you see here, notice how this one starts with the x term first and this one the y term is first. And that didn't matter before, but it matters now because keep in mind what we're doing. In hyperbolas we're doing a subtraction, and when you subtract things it matters in what order you subtract them. It didn't matter when we added, so it does matter what happens here. And the end result is then the thing you need to write down and memorize here is that if it starts with the y term first, here I have the y term first and the x term second, this will be a hyperbola that opens up and down. In fact, I'm going to show this to you right now. This is a hyperbola that will have its branches opening up and down. Conversely, if we come back here and the x term is first and the y term comes second, we're going to have a hyperbola that opens sideways, and I'll activate this one so you can see what I'm talking about. So this one, it really does matter which comes first, and we didn't have to worry about that before. I'm going to focus in on the one that you just completed the square for, this one here. Once you determine whether it opens up or down, there's not a lot of new stuff here. There's just a few things you do have to worry about. First of all is the center. The center will be done the same way as before, except you have to be careful about the order. We still do have x minus h here and y minus k. So if I'm looking here, my center should be at -1, -4. And if I click here, I should verify that that is where it is, right down here, -1, -4. And that's nice. And my email's on. Hi, email. Bye, email. Okay. So that's all set to go. So I have my center. Okay. The next thing I want to look at are my vertices, but notice how I have these labeled. A hyperbola actually has vertices and it has covertices. And what's meant by that is, since I know from my clues that this will be a parabola that opens up and down, the vertices are the points above and below. So it's going to be right around here and right around here. They're the points above and below because it opens up and down. The covertices will be the 2 points here and here that open left and right. And it turns out the vertices will actually end up being on the hyperbola and the covertices will not. And the way you find them is the same way you did it for the ellipse. The vertices, if I'm looking at the y, I see that I have my number here, my a squared is 9, square root of that is 3. That means I'm going to go 3 up and down from this point. We can activate those and see those clearly here and here. So those are my vertices. Okay, and you should go ahead and plot those. I'll turn these off. Okay. The covertices are going to be found the same way as we found them before. I have a b value of 4, square root of 4 is 2. Therefore, if I plot my covertices, they'll be 2 away, and you can see where those need to be. So things are starting to take shape here a little bit. Okay. We also have to deal with our foci. The foci, again, will be on the major axis. They'll be going up and down, so they're going to be up around here somewhere. Keep in mind that for hyperbolas, the foci are actually inside of the hyperbola, meaning that they are inside of the two bowls that you'll get inside the hyperbola. And one thing is a little bit different. Before, in ellipses, we had to subtract to find the foci. Here we're going to add, and I have it all here set ready to go. For hyperbolas, c squared equals a squared plus b squared. Kind of feels like the Pythagorean theorem. It kind of does. I have 9 and 4. This time I'm going to add. That's 13. That means from my center, I'm going to go up and down root 13, and I can see where my foci lie. Those are the green dots. Things are starting to take shape a little bit. I can kind of picture where my hyperbola is going to go. It's probably going to go something like this, and it's going to have its other bowl that goes something like this. So it's getting there. Now here's how you're going to shape what's going on. First of all, the line from this vertex to this vertex, it has a name. It is called the transverse axis. It is simply the line segment that goes from vertex to vertex. I'm going to show you what it looks like right now. So that's a brand new word. This right here is called the transverse axis. It goes from vertex to vertex. The one that goes from the covertice to covertice is actually called the conjugate axis. We're going to not worry about that one so much, but the word vertex and the term vertex axis is one you do need to know. All right, so now here's how we're going to make our hyperbola. The 4 vertices I have here, these 4 purple dots, you can see how they kind of make a box. You can see a rectangle here being established. What I want you to do is go ahead and, with dotted lines, go ahead and draw in this rectangle. And I can do it here through the power of Desmos. It's all set to go. I end up with this rectangle. Okay? This rectangle is going to help us out because it's actually going to help us make the asymptotes that are going to shape the hyperbola. Now, the asymptotes are imaginary lines. The imaginary line are going to start and they're going to go through the center here, and it's going to go through the corners of the box. So let's think about this a little bit. I have a point and I can figure out the slope. From here I want to go up 3 and over 2. I have a slope of 3/2. Well, I can go ahead and put that in. That asymptote is, if I put it in point slope form, you can activate it, and there it is. Actually, both of them lit up, which I really just wanted one of them to light up. Let's do that. So it goes through the center, up 3 over 2, and I can write the equation here in point slope form. So there's the equation of that asymptote. The other one will go instead down 3 over 2, and it's all set to go. So you might be starting to realize that hyperbolas take a little bit more work than some of the other shapes in order to do by hand. But actually we are in great shape now because everything is all set to go. Here are the clues. The hyperbola will come down, it will not touch this asymptote, it will come down, hit this vertex, bounce off, and come back up and not hit the asymptote again. Same deal here, this one will come up from negative infinity, not hit the asymptote. It hits the vertex, not the focus, and it backs down. So I think you're all set to go here. If I turn it on, see where it goes, I'm all set to go. It is a lot of work to go ahead and make these guys. You can kind of see where it goes, but you do need to know the words, so make sure you write down all the words. Very quickly, you might want to go through the other Desmos file of the one that opens sideways. You might want to go through all of these pieces and turn them on. You can walk through this set. Whoops. Turn this guy off. I'm going to go through the center, go through the vertices, covertices, foci, transverse axis, the box needed to make it, asymptotes. There's a lot of pieces going on here and a lot of contextual clues that eventually get us to the hyperbola we're looking for. There's a lot of stuff here. Okay, and that's it. You have 1 or 2 to do for homework, and good luck with that.